Alrighty, so today's lesson we're just talking about overlapping triangles. We've already done overlapping triangles, so these proofs should be very familiar to you, especially if you use your Bible/cheat sheet that we gave you in class. But the idea is when you're dealing with overlapping triangles, you might need to draw them separately, maybe pull them apart. But in this first particular picture, my guess is, if you haven't done this already, is that you are seeing three different triangles. You've got a little one here, you've got a bigger one here, and then a different bigger one on this side. Okay, so there's three triangles you should be seeing. On this next one, if you haven't looked at it already, take a quick look. You should be seeing 6 triangles here. You've got the big one, you've got a biggish one, another biggish one, so that's 1, 2, 3, and then you have all these individual guys. Then you have this guy over here, 4, this guy over here, 5, and this guy over here, which is 6. All right, so you might want to always redraw the overlapping triangles so that they're separate. You don't have to. I say always, but you do what you need to do. So for this particular proof, we're looking to get EC and FB congruent. And EC happens to be right here, where FB happens to be right here. So then one can really only assume that they want this triangle proven congruent, whoopsie, to this triangle. And then once those triangles are proven congruent, then by CP/CTC, you get your proof statement. So let's see what we can do here. Alrighty. So we've got AB congruent to DC, which would be this little guy to this little guy. So that's given. I'm going to stick with this before I do anything else because I want to get to this part being reflexive to do some equals added to equals. So I'm going to say 2 BC is congruent to BC. That's reflexive. Now we're going to do some some segment addition. Usually we do subtraction. This time we're doing addition. So we're going to take the two left pieces, AB plus BC, equal to the two right sides, DC plus BC. And this would be equals added to equals are equal. Now I stick with that left-hand side. Again, this is just like the subtraction piece, but now this left-hand side, AB plus BC, equals that one big segment of AC. And then on the other side, DC plus BC equals that one big segment, which is DB. So this then becomes your segment addition. Well, now and only now can I use substitution, and I can say then from 3 and 4, I know that AC must be congruent to DB by substitution. So if I were to redraw these triangles, if this is yellow and this is A, E, C, and then this is green, which is B, D, F. That's an F up there. So if I redrew that, then now I finally know that this guy is congruent to this guy. I've got some other givens here. The picture's going to go away because I've got to extend my page. So you're going to have to sort of follow along, and then we'll go back up to the top. But number 6, the next given that they tell you is AE is congruent to DF. That's given. And when I jump back to my picture, maybe yes, maybe no. When I jump back to my picture, I've got AE congruent to DF, which is here to here. And then I've got angle A congruent to angle D. Well, that's nice because that's over here. And now my triangles are congruent by side angle side. So let's finish this proof up. So let me bring this down again, bring this up. So 7 then becomes angle A is congruent to angle D. That was given. 8 becomes triangle AEC is congruent to triangle DFB. And that was because we did SAS. And then finally, your proof statement is EC is congruent to FB, and that's because of CPCTC. Let's see if I can get this all on one page. Come on. Try that. Come on, a little bit lower. There you go. Okay, so here's segment addition, which in the past we've had segment subtraction, the same 3 steps, equals to equals, segment addition, substitution. But you had to have 2 congruent segments before. One they gave you, one you supplied on your own. Alrighty, let's go to this next one. So this next one, I'm going to actually bring this back to normal page. This next one, they want you to prove angle AEB, which happens to be this particular angle, AEB, and they want that to be congruent to ADC, which is this particular angle, which means I bet you they want these particular triangles. So if you try to get a plan of attack from the beginning, I think you're going to make your life a lot easier. Let me get back in here. So this was the yellow triangle, this guy, and then this guy right here is your green triangle. Notice that you do have stuff that overlaps. It's the angle this time up at the top at A that overlaps. So that's going to be reflexive. You can pull the triangles out if you'd like. Let's see what we can do. So BD is congruent to CE. BD happens to be this little guy right here, congruent to CE, which is that little guy right there. And then they also tell you that AD is congruent to AE. I'm going to put these in the same given. So these guys are given. Well, what's nice is if I pull these triangles out, this is going to be my yellow triangle. If I pull out yellow, for up there is A, this is E, this is B. And then if I pull out my green, which this is still A, but this is D and this is C, this guy right here gets me into these 2 sides. What's also interesting is these 2 together, BD and AD, also get me to a big side. So let's see if you're going to see that. I'm going to go right here and do some more addition. I'm going to say BD plus AD equals CE plus AE equals added to equals are equal. I'm going to take the left-hand side and say, well, BD plus AD, when added, gives me all of AB. And the right-hand side, when I take CE plus AE, that gives me my entire right-hand side, which is AC. This is segment addition. And then lo and behold, I can substitute, which says for AB is congruent to AC. So now I have AB congruent to AC. What's next is that angle that we shared, or we showed, was shared with both. So all the way at the tippy top, angle A is congruent to angle A, and that's reflexive. So let me just kind of go back up to this picture. Once I get this angle right here, that's a part of both triangles, you have an SAS. So we've got an SAS and then a CPCTC. Let's finish this thing up. Number 6. What do we got? triangle BAE is congruent to triangle CAD. And again, we said this was side angle side. And then finally, what they're having you prove is AEB is congruent to angle ADC because corresponding parts of congruent triangles are congruent. Okay, full page. Now, some of you might have been able to figure out another way to do this proof, and that would be by proving the bottom triangles DBC and ECB congruent. You could have done that as well. So just so you know, there is a different way to do this, where you get these guys down here congruent to each other. Okay, so maybe you want to take the challenge and try and see if you can do this proof a different way. You only need one way to do it. Whatever you see is fine. Last but not least, we got this guy. Alrighty, so let's see what's going on here. They want you to get into AE and CD. So they want you to get into AE, and then they want you to get to CD, which I bet they want you to go for this overlapping triangle with this one. Okay, and let's see how that works. Okay, angle BDC and angle BEA given. So BDC happens to be this angle in yellow. BEA happens to be this angle in green. Let's separate these two. This triangle right here is BEA. This triangle right here is BDC. And they told you that BDC, this guy right here, is in the yellow triangle. This guy right here is in your right triangle. All right, so that works. They also tell you that angle, I guess I'll leave this in here, angle A is congruent to angle C. We'll keep that in our given. So this is in our green. This is in our yellow. All right, well, that's nice. So it looks like all we have to do then is just figure out another side. So we need to kind of look at something we talked about yesterday with isosceles triangles. So would you guys agree, not that you can even talk to me, but if we were looking in this big triangle, A, B, C, and you know that from that second given that this is congruent to that. If you're in a triangle and two angles are congruent, aren't the sides opposite them congruent also? Those sides end up becoming here and here, which is here and here. There's your triangle, and it's through AAS. So I'm going to have to write this down. I'm going to say, okay, well, line segment AB is congruent to line segment BC, or CB if I did this correctly, and then here's what I'm going to write. In a triangle, angles, that's not true of sides. In a triangle, might as well erase this thing. And just in actually what we'll do here also is the triangle that we're referring to is this big triangle ABC. So in triangle ABC, sides opposite congruent angles are congruent. So there we have that. Number 3, triangle BDC is congruent to triangle BEA, and we just said this was AAS. And then finally we can say AE is congruent to CD, and that's because of CPCTC. All right, so there you go. Again, it's nothing new. The triangles are overlapping. They're still dealing with equals to equals. You're still dealing with stuff from like isosceles triangles, but the theorem piece of it, eventually you'll get to angles that are supplementary to congruent angles, et cetera, okay? Tomorrow is just more of this. All right, good luck.